All right, so let's see this particular question. So in this question, we are given a numbers table and it has two columns, a num and the frequency, right? And what they mean is that this num column can have different numbers, like over here we have 0, 1, 2, 3. And this frequency actually tells us how many times this number appeared in a given database, right? So, or how many times this particular number is stored in a database, right? So for example, 0 is stored 7 times, 1 is stored just once, 2 is stored 3 times, and so on and so forth, right? So this is the meaning of this particular table. Now let's read the question and see what we need to do. So first, they have given the definition of the median. So median. So the median is the value separating the higher half from the lower half of a data sample, right? What we need to do is we need to write a solution to report the median of all the numbers in the database after decompressing the numbers table. And we need to round the median to 1 decimal point, right? So basically they are asking us to first decompress this particular numbers table and then find the median, right? And what they mean by decompressing this table is that right now, if you see, this is aggregated table, right? So right now they have told us, like this table tells us that number 0 appears 7 number of times in the database, but I don't see 0 repeating 7 times over here. Similarly, it tells us that 2 appears 3 times in the database, but I don't see 2 actually appearing 3 times or 2 listed 3 times over here in this particular table, right? So if I decompress this particular table, I will be having 0 repeated 7 times, then 1 just once, and 2 repeated 3 times, and then 3, right? So in total, there will be 12 rows, that I will be having in my decompressed table. Why 12? Because if you sum all the frequencies for each of the number, it will come out to be 12. 7 plus 1 plus 3 plus 1, right? So in total, there will be 12 rows and the numbers will be repeated, uh, with their corresponding frequencies, right? So one part of the question is that, and after we have decompressed the table, we need to find the median of, this particular data set, right? So by that, what we mean is, for example, if 0 is appearing 7 times and 1, and in total we have 12 number of rows, so then the median would be 12 divided by 2, that is 6, and 6 plus 1, that is 6, and 7th position number would be the median of this particular, like again taking the average of those two, would be the median of this particular data set, right? So over here, if you see, in total we have 12 rows. So the median positions would be 12 divided by 2 and 12 divided by 2 plus 1. That would be 6th and 7th position. And if you see 6th and 7th position, both will have 0, right? And if I take average of 0, it will be 0, and that's why the output is 0, right? So that's what we need to do. We need to decompress this table and find the median. And similarly, if there were not 12 rows over here, but just 11 rows, then that would have been the case of odd number of rows, right? And in odd number of rows, we will have just one median position, which will be total number of rows divided by 2, and then the ceiling of that, right? For example, if 11 is the total number of rows we have, then it will be 11 divided by 2, which will be 5.5, and then the next integer value, the ceiling, which is 6. So the sixth position would have been the median, right? So that's how we have to calculate the median after decompressing this particular table, right? So now maybe you can just pause this video and think of a solution, maybe try to write a query for this. And once you are done, maybe you can come back to check your solution or to understand the solution. Okay, so let's like briefly talk about how we can actually approach this particular problem. So there are two parts to it. As we discussed, first we have to decompress the table and then we have to, you know, find the median. So to decompress this particular table, what we can do is we can try to use a recursive CTE, right? And using a recursive CTE, we can actually try to mimic the expanded version of this particular table, right? And once we have expanded this particular table, then it will be pretty easy for us to assign row numbers to every row, order by the number, and then to find the median positions corresponding to that particular data set, right? So yeah, I think that's how we can approach this particular problem. Maybe we can start to write the query together for this, and once we write the query, you will get a better understanding of how to actually implement this recursive CT and then finding the median. So let's just jump to the IDE and start writing the query. All right, so now let's write the query for this particular solution. So now, as we discussed, we will first have to decompress the numbers table. We will have to expand the numbers table, and for that we can make a use of the recursive CTE, right? But for those who don't know like how a recursive CTE works, I just don't want to like write some text and tell you that this is what it will do. I really want you to understand how a recursive CTE will work and really, feel the solution in a way, right? So what I will do is I will first explain, how a recursive CTE works by taking this particular problem statement only. But if you're already aware, if you have already worked with recursive CTs extensively, you are like thoroughly aware of recursive CTs, then maybe you can forward this video a bit and you can continue from there. But if you are not aware of recursive CTs, I highly recommend you to actually listen to this, right? So if I just select from the numbers table, there are two columns. So I will select num, comma, frequency, right? From numbers, right? Now, if I select this, I will get 0 and 1, 2, 3, and then the corresponding frequencies, right? What I want is out of the result, as a result of my recursive CT, I want this 0 to be repeated 7 times, 2 to be repeated 3 times, and then 1 and 3 appears just once, right? Basically, every number repeats as many times as the number, as the frequency of that particular number, right? So what if I implement something like this, which is like a very trivial thought, right? What I can do is I can just maybe declare one CT with CT say 1 as, and put this over here, right? And then what I can do is I can declare another CT2 as, right? And then what I can do is I can copy this, and now I can select from CT1, right? Rather than selecting from numbers, right? And now if I do a union like this, select star from CT1, union all, select star from CT2, right? If I do this, I will have every number repeated twice, right? And I can keep doing this manually, right? For example, if I want 0 to be repeated 7 times, I can keep creating those many CTs and keep unioning all, right? But if you see over here, the frequency of 1 and 3 was just 1, right? So I didn't want these numbers to be repeated. Whichever have frequency 1, those should not be repeated, right? Only the ones which have greater than 1, those should be repeated as many times as the number of, as the frequency of that particular number, correct? So what can I do, right? Maybe I can put a where clause over here that if the frequency is greater than 1, only then you select it in the CTE2 and then union it with the CTE1. Otherwise, you don't select it in CTE2. It is already present once in CTE1, and so it will be good, right? So now if I run this, uh, this will just repeat 0 and 2, right? It won't repeat 1 and 3. That's what I wanted, right? Now the ones which have frequency 1, like the numbers which have frequency 1, those won't get repeated. Only the numbers which have frequencies greater than 1, those are getting repeated, right? Now, for example, this 2, again, I want to repeat it one more time, right? Because this is supposed to be appearing to like 3 number of times. So what I can do is I can maybe create another CTE manually, right? Like this. And I can now select from CT2 rather than CT1, right? And again, I can use a union all to union this new CT as well, right? Like this. Now, if I run this, I will just remove the comma. And if I run this, now if you see, 2 gets repeated 3 number of times, right? 0 also repeats 3. I mean, that's a different thing. We have to repeat 0 4 more times, but 2 gets repeated 3 number of times, right? Now, since I need to repeat 0 also like 0 4 more times, what I will do is I will again like repeat this, create another CT, and this time I will name it as 4, and this time I will select it from 3, and I will again union it, right? Now my no other number should get repeated, right? It should only repeat 0 now because 0 is the one that is having frequency greater than 3, right? So now if I run this, 0 definitely gets repeated 4 number of times. But if you see now, 2 has also repeated one more time, right? 2 was not supposed to repeat beyond the third repetition, but it got repeated in the fourth as well, because the reason for that is that we have definitely put this condition frequency is greater than 1, right? But we are still referring the original frequency from the base data. We haven't made any change to the frequency as such, right? So what we can do is we can keep decrementing the frequency in every CTE, right? When we are selecting from the last CTE, we can just keep decrementing the frequency so that, with every repetition, because see, the meaning of every CTE is to actually do one repetition. So if I've done one repetition, then I can actually reduce one from the total number of times it was supposed to be repeated, right? So I can just do frequency minus one whenever I'm selecting from the previous CTE, and then I can check if the frequency is greater than 1. Only then you repeat it, otherwise you don't. Now if I run this, right? Okay, so what is the mistake that I did? Okay, yeah, I need to alias this, say as frequency only, right? I will just copy this entire thing and put it over here and here as well, right? Now if I run this, now you see 0 gets repeated 4 number of times, 1, 2, 3, and 4. But 2 doesn't get repeated beyond the third repetition, right? And now if I keep unioning more also, it will just not repeat 2. It will just repeat 0 till 7 repetitions. Because after 7th repetition, 0's frequency will also become less than 1 or equal to 1. And that's why it will not fall. It will under this particular where condition for the last CT, and it will not get repeated, right? So this is how I can manually, if I keep creating CTs and keep doing this frequency minus one and put a where clause, and that frequency should be greater than one, and keep selecting from the last CT always, then I can, do this expansion basically, right? So this entire thing, of using different CTs and every time in the new CT, referring the last CT and then, selecting frequency minus one, this can be actually automatically handled by a recursive CT, right? So what we can do is we can actually declare one CT. We can call it as CT explode maybe, right? And if I write something like this, initially I will write the base query, right? Whatever I wrote in CT1, right? I will just write it over here, right? This will select the original data. And now what I was doing was I was actually unioning different CTs together, right? So I will do the same thing over here. I will do union all. And now this is my anchor member, right? To be more like technical, this is called anchor member. And now I will have a recursive member over here, right? And this recursive member will automatically do what we actually did manually over here. It will fan out different child CTs, right, out of the main CT, and it will keep recursively calling the last CT to calculate the new CT, right? Whatever we were doing over here, the same thing will be recursively handled by this recursive member over here, right? And the way we write it is, it's pretty simple. We don't have to worry about how it is happening underneath, but then we just have to make sure that we refer back the original CTE, right? So now if you see, now in the base member, in the anchor member, I'm selecting number comma frequency from numbers, which is the base data, and then I'm unioning it with select number comma frequency from the CTE itself, right? So now it will keep calling this CTE over and over again, right? And it will keep selecting from the last added results, right? And that last added result in our language is the last CTE that we were creating manually, right? And obviously we will have to do -1, and we will put the same condition over here, that so that our recursive CT knows that where it needs to terminate. It needs to terminate whenever the frequency is greater than 1. So now it will yeah, I think this is fine. Let me just test this CT if there is no syntax error. Select star from CT underscore explode. Yeah, so now this gives me results just fine, right? Now what we can do is we can just, like, after having expanded this particular table, what we can do is now we can find the median. So I can select from this particular recursive CT and I can assign row numbers, right, to this expanded data, and I can do that over order by num itself, right? And I can just rename it as RN, right? And also what I will do is I will find the total number of rows in this particular data set so that I can use it to calculate the median positions, right? So for example, if over here the total number of rows are 12, I will then do total divided by 2 and it will give me 6. So I will know that 6 and the seventh position will be the median, right? So I will need to calculate the total number of rows. For that, I can do a simple count 1, right? And I will do a over clause without an empty over clause basically because I'm not partitioning. uh, I'm doing a count over the entire data set and not on any partition. So it will be count over and I can just rename it as total, right? Now what I can do is I can write another query on top of this subquery. I can do select from, right? And now I can put the where condition as where rn, my row number, is equal to total divided by 2, or Rn is equal to total divided by 2 plus 1, right? So these will be basically my median positions, and I'm going to select only those rows where the row number is either equal to total divided by 2 or total divided by 2 plus 1, right? Those will be my median positions. But now this will be true in case of the even number of rows. Like if I have total rows as even, this will work. But then, for example, if I have odd number of total rows, this won't work because this particular condition in particular uh, won't be true, because over here, for example, if I have 11 as the total number of rows, this 11 by 2 will give me 5. It won't give me 5.5 because this is integer division. So we have discussed this before also in another problem. I will share the link of that particular problem with this video. But essentially what we mean is that this particular integer division will truncate the decimal number and it will give the lower nearest integer, right? So if it is 5.5, it will give me 5 and I will end up selecting row number 5 and then row number 6 as the median for the odd number of total rows, right? But I'm not supposed to select row number 5. I'm only supposed to select row number 6, right? So what I can do is instead of having an integer division, I can convert it into a float division, and that way it will give me now 5.5 if total is 11, and there will be no row number with decimal points. Row numbers will always be integer, and that's how I can actually make this particular condition null and void in case I have odd number of total rows, right? And with this particular float division, even if I have even number of total rows, still even number of rows will be fine, because if I have, for example, 12 divided by 2.0 will still give me 6, right? So that 6 will then be like matched with the row number 6, and it will just return that particular number, right? So that's why with even number of rows, this particular condition will then hold true. But for odd number of rows, it won't hold true, right? It will be like null and void. And this will anyways be the same. It will give me the correct result both for even and the odd also. So this will be kept as is, right? So finally, what I can do is I can select the corresponding number, right? And I will take the average of it, because if there are two median positions, as is in the case of the total number of rows when they are even, so I will take the average of both the numbers, and I will also like cast this particular number as float, because while taking average, I don't want to lose the decimal precision, right? So I will cast it as float, and also in the question, as we are told that we need to round up till one decimal position. So I will round it off to one decimal, right? Like this. And hopefully this should work if there is no syntax error or funny mistake. Yeah, this is fine. And I can just rename this column as median, and now this will be my final output. Yeah. So I hope you understood. This was a long video, a long solution, because I took the initiative of, kind of explaining how a recursive CTE works. I'm not sure how successful I was, but do let me know in the comment section if you want more explanation. I will create a dedicated separate video only for recursive CTEs, and then it will be more like clear to you. But I hope from the point of view of this question, at least you would have understood what we are trying to do, right? So yeah, and I'll see you in the next video. Thank you.